Assalamualaikum and hi everyone. Today we will presenting about field trip presentation of soil in Kuantan Pahang. Our team members is ADEESAK, Nazirul Syahmi, KHANATHEEBAN and I FATIHEIN HUSNAINI. October 26, 2024, the soil science subject held a fieldwork in Kuantan Pahang. The fieldwork station is at Mardi Serating in Kuantan. The visit aims to learn and experience soil formation, degradation and conservation in this area. We arrived at Mardi Serating around 9 a.m. After the briefing session, we need to choose one soil series to start our task and we choose Jumbo soil series. We were given 3 hours to collect the data on the soil profile, properties, parameter and more. For the type of soil in the Jumbo series is typic quartzite. This type show that the soil is high in quartzite mineral and is lighter in color. Moreover, this type of soil lead to low fertility and high permeability. The land used for this area were included coconut tree, grass and guava. The objective for this presentation is to expose the student to actual soil condition in the field, to train student knowledge on soil through group study and discussion, to develop students' ability in analyzing environment impact on improper management of land. Coordinate data that we get from Serating Mardi is 4 degree 4 minutes 29.1 second north and 103 degree 22 minutes 54.4 second east.
Okay, hi everyone. Today I'm going to talk about the soil formation at Mardi Charanting. First up, we take a look at parent material. So it developed from sandy parent materials that are rich in quartz. These deposits are primarily composed of weather granitic or sandstone materials, resulting in their coarse and sandy texture. Second is climate and weathering. It was characterized by high temperatures and heavy rainfall accelerates chemical weathering of rocks. However, quartz being resistant to weathering remains as the dominant mineral. Rainfall also reaches soluble minerals and nutrition out of the soil, leaving behind a nutrition poor sandy substrate. Third is topography. Elevated areas remain excessively drained, contributing to the rapid loss of nutrients and organic matter, while lower areas may retain slightly more moisture. Fourth is horizon development. The surface layer often contains loose sand. There is little to no the accumulation of clay, organic matter or iron oxide in lower horizon. The profile lacks significant differentiation consistent with young soil.
It's the development and we use measuring tape, shovel or spade, and then who master soil color chart and towel. For the method, we choose a representative location and then we use a shovel or spade to dig a pit about 1.22 meter, depend on the depth of interest and soil type. And then we use a soil auger to extract soil sample by layer. And then we use a towel to smooth the pit wall for a clear view of the horizon. And then we identify the horizon, identify the structure, texture, and also the color of the soil. Okay, now I will explain about the study on soil profile, which determine the soil color, horizon, thickness, root, soil structure, and also the soil texture. First, we have the soil color. At the multi-charting, the indicator to determine the soil color is to reflect organic matter contents, mineral composition, and drainage. So how we observe? We use a Marcel soil color chart to identify hue, value, and chroma. So the color of soil we have is dark brown, which is contain high organic matter. That's the horizon. In this place, we found 7 layers of the soil, which is A horizon, topsoil contain high organic matter and dark in color. And next, we found E horizon, which is this layer with loss of silicate clay, iron, and lighter in color. Then we have transition zone, and then B horizon, the upper subsoil, and then the middle subsoil, and also the lower subsoil. And then the last one, we have bottom horizon, which is C horizon. For the thickness, we can measure the thickness of each horizon from the soil surface using a measuring tape. And horizon thickness provide clue about soil development stages and the intensity of soil forming processes. Okay, next is the soil texture. At the Madi Cerate, we found the soil texture is sandy soil. How we find it? We use a method. We take the some soil sample. We rub soil between fingers to feel coarseness or smoothness, and then to know that the texture affect metal retention, drainage, and root penetration. Well, that is the soil structure, the arrangement of soil particles into aggregate or clumps. Type of texture we found at the Madicate is granular, which is common in topsoil, good for root growth and water infiltration. And the last one, we have the roots to indicate the soil health and fertility. So type of root we found at the Madicate is the abundant roots, which is good aeration and have more nutrients.
Profile description and elevation. Our site height about 180 cm, which divided by 7 horizon. The first one is top layer, A horizon with 21 cm height, E horizon with 24 cm, transition zone 44 cm, B horizon with upper subsoil 21 cm, B horizon with middle subsoil 9 cm, B horizon with lower subsoil with 35 cm, and C horizon with 26 cm of height. Profile description and color code. For top layer, A horizon 10YR 3/1 very dark grey, E horizon 10YR 6/1 pale grey, transition zone 7.5YR 7/2 pinkish grey, B horizon upper subsoil 10YR 8/3 pale very pale brown. For B horizon middle subsoil 10YR 6/6 strong brown, B horizon with lower subsoil 10YR 5/5 dark yellowish brown, and lastly bottom layer there are C zone C horizon with 2.5YR 5/6 reddish brown. Next is profile description, organic matter and drainage level. For top layer, that's our A horizon, the drainage level at class 7 that are well drained and have grass root. For E horizon at class 7 that are well drained and still we still found a root. For transition zone, B horizon with upper subsoil and B horizon at middle subsoil, the drainage level at class 7 they are well drained and we found no organic matter. For B horizon with lower subsoil that are class 7, they well drainage and we are found some root. Meanwhile, for bottom layer, there are C horizon. We classify the drainage level at class 6. They are the soil drainage moderately are well drained.
And then for soil identification and mineralogy, for the mineral, we have found the quartz, which is dominant in the sand and silt section and is undoubtedly of inherited origin, deriving ultimately from igneous and metamorphic rock. This we found at the Madi Cerate.
Next is I'm going to explain about the properties of soil at Madicharate. First up, we take a look at physical properties. The texture of soil was predominantly sandy with a high proportion of coarse grains. Next, it often contains over 90% sand with minimal clay, less than 5% and silt fraction. Their porosity was very high due to pore structure, but pores are predominantly macropores, leading to rapid damage. Their color is light light in color, typically pale brown, yellowish, or grey, due to the dominance of quartz and minimal organic matter. Second, second is chemical properties. Their fertility was very low due to minimal organic matter content, poor cation exchange capacity, also known as CEC, limiting the soil's ability to remain nutrients, deficiency in essential nutrients such as nitrogen, phosphorus, and potassium. Their nutrition retention was extremely low due to the lack of clay and organic matter, both of which are critical for holding nutrients. Okay, um, we were using clinometer to measure the slope at Marti Cherading. So we took 5 reading of this. The first reading was 292 degree. The second reading was 298 degree. The third was 296. Fourth was 294, and the last reading was 14.
There are many factors that cause soil degradation observed in the area. The first one is erosion by wave action. As the area is nearby to coast shoreline, the wave gradually washes away the fertile topsoil, making it depleting of nutrients and organic matter on the soil. The second one is low water retention. As the soil is sandy, it has low water retention, causing the moisture to die very quickly, leaving very little water for the plants to absorb. The third one is increased seawater level. Due to climate change, seawater level has risen gradually, causing soil salinization, which increased the amount of soil in the area, making it not suitable for many species of plants that cannot withstand the salinization. The last one is altered precipitation pattern due to climate change, which can cause long period of droughts. In order to conserve and restore the soil quality, it should start with sustainable management of the land, which, for example, we can use tillage technique to provide a natural barrier for the soil. The next one is avoid over-irrigation because it can lead to waterlogging and promote soil salinization. Proper irrigation technique should be applied to maintain and improve good moisture level of soil. Moving on, since there are animals such as cow and goat live in the area, we can use the natural fertilizers coming from them. These can improve the soil structure and enhance soil microbial activity, which also can lead to enhancing soil biodiversity to create a balanced and healthy ecosystem for the soil.
Next, for agriculture suitability, the texture and pH, the soil particle size about 0.2 mm to 2.0 mm with a gritty texture, and acidic range with the range of 4.5 to 6.0 pH. Meanwhile, for organic matter and nutrient, the organic matter in sandy soil is less than 1%, thus the CEC is low with 3 mol per kilogram. So next is water retention and aeration. Larger particle in size in sandy soil allow water to drain quickly. It also low water and nutrient to hold capacity, thus struggle to retain sufficient amount to crop. So for solution in Jambu series, the first problem statement, soil conditions are less fertile from the aspect of nutrient, organic matter and the ability of soil to hold water. So for the solution, Mardi conducted a study and started a method to increase soil fertilizer levels is to use Napier, or better known as Napier grass fertilizer. This fertilizer is better to increase the level of soil fertility for planting various types of trees in the Jambu series such as coconut and guava trees. In addition to sandy soil, using manure from animal feces is one of the best way to increase soil fertility, organic matter and CEC of the soil. The next station is at Teluk Cempedak. We arrived at 1 p.m. and we were given 1 hour to complete the task. The land use of this place is secondary forest reserve. Minute data at Teluk Cempedak that we get is 3 degree 48 minutes 52.3 second north, 103 degree 22 minutes 6.6 second at east.
Next up is the soil formation of Teluk Cempedak. First, we have parent material. The type of bedrock or unconsolidated material in the area acts as the base for soil development. Second is climate and weathering. The tropical climate of Teluk Cempedak contributes to intense weathering of parent material due to abundant rainfall and high humidity. Promote rapid chemical weathering and organic decomposition, leading to nutrient-rich topsoil. Third is topography. Slope areas might experience soil erosion due to rainfall, while flat areas may have thicker soil profiles as material accumulates. Fourth is horizon development. So there are 4 layers. So the top layer was O horizon. It was rich in the organic matter due to decomposition of leaf litter. The next layer is A horizon, a fertile layer of mixed minerals and organic material. Third layer is B horizon, the accumulation of niche minerals like iron and aluminium. And the last layer is C horizon, weathered parent material.
For the development and morphology of soil, we use the material measuring tape, shovel, hoe, muscle, soil color chart, and towel. And then for the method, firstly, we choose a representative location, use a shovel or spade to dig and pit about 1.22 meter deep, and then depend on the depth of interest and soil type, ensure the wall of the pit are vertical for clear horizon observation. Use soil auger to extract soil sample layer by layer from various depth. And then we use a towel to smooth the pit wall for a clear view of soil horizon. And then next we identify the horizon, and then we identify the structure, texture, and also the color of the soil. Okay, this is the picture on how we determine the horizon and also the color of soil at the Teluk Cempedak. The first picture show that we dig a soil, depend on the soil type, we dig into 1 to 2 meter, and then we use the what we call it the measuring tape at the picture of the T, picture T. We use the measuring tape to determine to measure the soil and also to determine the horizon. And then the last picture, we take the soil sample and then we compare it to the Marcel soil color chart to determine the color of the soil at the Teluk Cempedak. Okay, for development and morphology of soil, study on soil profile. For the soil color, we found at the Teluk Cempedak, the color of soil is grey or bluish, which is poly drainage condition. And the horizon, we found at the Teluk Cempedak, in this place we found 5 layer of soil, which is A horizon, topsoil contains high organic matter and darker in color. E horizon, this layer with lots of silicate clay, iron and lighter in color. B horizon, subsoil, which is we found upper subsoil and lower subsoil, zone of accumulation. And the last one is soil C horizon, which is the bottom layer. And the thickness, we can measure the thickness of this horizon from the soil surface using a measuring tape. Horizon thickness provide clue about soil development status and the intensity of soil forming processes. Okay, next the soil texture. At Teluk Cempedak, we found the texture of the soil is clay soil, The method also same at the body. We take some soil sample, rub soil between fingers to feel coarseness or smoothness. For the soil structure, type of structure we found at the Teluk Cempedak is massive, which is no visible structure and have a poor drainage. And the root type of roots, which is shallow roots, which has a poor drainage and compacted layers of soil. Okay, this is the profile description and elevation. Uh, for the soil profile and for the height of the soil at the Teluk Cempedak is 105 cm. For the top layer, A horizon which is 12 cm, E horizon 41 cm, B horizon upper subsoil 12 cm, and then the lower subsoil B horizon which is 19 cm. Bottom layer C horizon 20 cm. For the profile description and color code, top layer A horizon 10 YR T/2 dark brown, E horizon 10 YR 7 pretty light yellow UVs, B horizon upper subsoil 7.5 YR 6% reddish yellow, B horizon lower subsoil 2.5 YR 4 pretty reddish brown, bottom layer C horizon 7.5 YR 6 pretty light brown. Next is the profile description, organic matter and drainage level. Top layer A horizon class 7, well drained and have grass root. E horizon class 7, well drained and still found root. B horizon upper subsoil and also B horizon lower subsoil, class 7, well drained and still found root. And the last one is bottom layer C horizon class 7, well drained and still found a root. Also at Teluk Cempedak, we found the mineral of the soil is the quartz.
Okay, next we are going to talk about the properties of soil at Teluk. So we take a look at physical properties first. Their texture is usually sandy loam to clay loam, depending on the parent material. Next is bulk density. It was lower than distributed distributed areas, indicating better soil structure. Third is their porosity. It was very high, allowing good matter infiltration and aeration. Fourth is moisture retention. It was moderate to high, influenced by organic matter content. So their color, it depends on the factors such as the organic matter content, mineral composition, and drainage conditions. For example, at A horizon, the color will be dark brown to black due to higher organic matter content. The B horizon will be reddish brown, yellow or orange, caused by the iron oxide accumulation. Next is chemical properties. Uh, their pH was slightly acidic, maybe around 4.5 to 6.5, common in tropical forest soils. Second is the organic matter. It was moderate, reflecting the accumulation of leaf litter and vegetation. Third, their nutrients was lower levels of nitrogen, phosphorus, and potassium compared to primary forest, but still higher than degraded soil. Their cation exchange capacity, known as CEC, was moderate, influenced by clay and organic matter. These are the slope readings that we took at Teluk. So the first reading was 42 degree. The second is 46 degree, the third is 44 degree, the fourth is 288 degree, and the last reading is 290 degree.
There are many factors that cause soil degradation observed in the secondary forest. The first one is obviously due to deforestation and logging, which soils were being exposed to harsh environmental conditions, making the erosion becoming worse and the soil fertility decline. Another one is soil compaction. Heavy machines during logging can cause compaction of the soil, reducing pore spaces within the soil. The soil provides less support to the root system, as well as making it harder for water, air, and also nutrients to penetrate into the soil. Last one is depletion of nutrient availability. Because in this forest where there might be important or rare earth elements, many people might illegally obtain these elements and can cause damage to the soil, especially to the nutrient disruption. In order to conserve the soil and restore the soil quality, we should start with erosion control by planting more native plants so that regeneration of forests can happen. The second one is using agroforestry crops or green manures in order to improve the soil's fertility. And the third one is the basic one, which is to avoid disturbing forest floors such as burning or logging activities. And the last one is to improve drainage so that we can reduce waterlogging in the area. As conclusion, this field trip provided insights on the complexity of soil within the types, the soil profile, the process, and also the degradation condition. This field trip allowed us students to first-hand witness the soil condition and also evaluate and analyze the problem of the soil in different geographical setting or area. Through this field trip, students were exposed with real-life challenges in soil management and environmental conservation. While coastal area negatively impacted due to erosion caused by rising sea level and also human activities, secondary forests are affected due to logging and deforestation, which resulted in nutrient depletion. This field trip underscored the importance of soil conservation techniques in both coastal and secondary forest settings. I think that is all from our group. Thank you.